In this Grasshopper tutorial, I will be demonstrating how to turn any curve into a wall with a given width and number of stones. And as you can see, all of these values are adjustable, which is what makes this design parametric, was what makes this software so powerful. So I'm going to disable this algorithm so it stops using up my computer memory. And now I'm going to recreate it down here. So I'm going to take this curve into Grasshopper by using the curve container. I'll right click on it, set one curve, and I've brought this curve in, and let's offset this curve to give it some area, and this will be the area that the wall takes up. And we need to close off this region by adding end caps. So we'll open up endpoint nodes and connect those onto each of these curves so that we can put lines between the start and end, the start of each of these curves and the end of each of these curves. And in this way, we'll create end caps. So if we use a boundary surface and plug these in as the edges, using shift to plug in multiple wires, then we have found an area region. It didn't work because these edges are in different groups, so what we have to do is flatten this list and put all of these edges into the same group, and now it works. And we can extrude this surface that we have just created in the Z direction in order to turn this surface into a volume. All right, let's give it a height of 2.00, 2 decimal places of precision, and let's start adding some labels for clarity. This is our height. And let's drag it to the front where we're going to consolidate our inputs. And let's also plug in a copy of this number slider to this distance here, which is the width of the wall. Great. So now let's populate this volume that we have created with stones. And I will be demonstrating how to do that. Well, we're going to use the populate 3D node, and we could use the populate geometry node, but this will create points on the surface. We want to create points within the volume, so we're actually going to use populate 3D. And you'll notice that it doesn't create points within the volume, it creates points within the boundary of this volume, the bounding box, right? This is the equivalent. So what we have to do is find out which points are inside of the brep. So look up the point in brep node and see if these points are within this brep. And right now, I believe none are, but if we give this a larger number, then I'm sure that some of these will be. So let's cull pattern to delete these points based on whether or not they are inside. And as you see, these are the points that are inside and everything else has been deleted because we have extracted true or false values based on whether or not a point is inside or outside, and then deleted based on those true or false values. Great. So let's preview everything else off. And now if we use the voronoi 3D node, we can turn all of these points into volumes. But we only want these volumes where they intersect with the wall. So what we'll do is use solid intersection right here, and we will find where these breps intersect with this extrusion. Great, my computer is doing some thinking, and we can preview everything else off. We have just found our cells. But so far, they're not going to look very good because there's no gaps between them. So let's scale down each one of these cells based on its center. So we'll find its center using the volume, or excuse me, we don't actually need to find the center because we already know where the centers are. The centers are the points that we have fed into the voronoi. So we can use these as the centers. We'll scale these geometries, and let's give it a factor between 0.9 and 1.00. Great. So if we plug this in and preview this off, now we have gaps between stones. Let me just hook up a custom preview so that you can see it more clearly. And the one thing we're missing is the grout, the infill, the cement, the thing connecting the stones. So how we can create this is we just take our extrusion, but we take a smaller version of it, and we call it grout. So to create a smaller version, let's take all of these curves right here by copy and pasting this node, and let's join these curves. How am I going to do that? I'm going to go Command Shift on a Mac or Control Shift on a PC, and I'm going to drag these curves into the join curves input, And now we've got one closed curve, except not yet because we have to flatten this list. And now we have one closed curve. And we can offset this curve in order to make it smaller and to create a smaller extrusion. We'll give it a distance between 0 and 1 with 2 decimal places and see what happens. Great, it's offsetting inward, so that is perfect. Now all we have to do is extrude the curve in the Z direction. And how far do we want to extrude it? Well, we want to extrude it the height of the wall over here, but we want to subtract this margin that we have just created. So we take the height and subtract from it this boundary margin that we want to offset the grout inwards into the wall. And we will add a cap to the holes here. Great. And now we have created an inner volume, and we can also give that a custom preview, and this will be the infill. You may be noticing that there is an issue here, and it is evident right here. And one way we can fix that is by taking our Voronoi 3D and making sure that we plug in the correct box, because we forgot that step. So we'll use this bounding box and make sure that we're not cutting off any of this wall. And now you can see my program updated, and if I add some colors, it will begin to look a little more realistic. Great. This is all about creating stone walls in Grasshopper. Please like and subscribe. There will be many more videos coming soon.